Good morning, everyone. Um, my name is Jasdeep Singh. I'm very recently joined a research scientist at the University of Illinois, working with Andrew Margenot in his lab. Today, I'm going to talk about a very recently newly funded ISA project through their check of money. The project is about, it's a long title though, but I highlight some keywords here. It's about investigating soil health, water quality, and climate footprints from Illinois soybean production system. So in this quite a brief summary, I will, as I mentioned, it's a very newly funded project, just started a couple of months ago. We do not have any data or anything to share about, but we'll give you the brief flavor about what we are doing, how we are doing, and where we are conducting these experiments. And in the future, you will see more frequently me and maybe Andrew in our meetings, and we will talk about as the results come out from this project. As I just mentioned, it's a new project, a new partnership between the ISA and UI and I. As Stephanie just mentioned, they love to create such kind of videos and outreach as you, and in the future we'll be also doing such kind of videos. I'm not going to play anything, but just a heads up there. As you could, as we move forward, we will be having such kind of more videos coming out, just sharing the results. On their website, you could also find things like they have one special page dedicated saying the Margenot soil quality. In here, we will be frequently, as data comes out, we'll be putting up our results and more in a non-technical way so that you can better understand. And we are very grateful to the Soybean board for funding, and we are very excited about conducting this research. Brief overview of our team, which is led by Dr. Andrew Margenot. He's a PI, and you will see him speaking at the Soybean Summit at the Champaign in the 2nd February, I believe. And then we have Heidi as a PhD student. She's going to work most of our doctoral research, currently working as a master's in our group. And then I will be a project scientist, will be responsible for day-to-day activities and what's coming out from the research, and then sharing with the Soybean board. And then we have excellent support staff helping us, conducting the experiments. For example, Michael, he has a tremendous experience running up the farm. Himself is a farmer, so he has a lot to help us there. We have other support, as the data collection takes a huge efforts, manual and as well as other non-technical labors. We have a Cato and Guadalupe. She's a new intern here and will be also supporting us in this project. Yeah, so there's quite a good team. We are very excited about running this project. Brief overview. We want to benchmark and integrate soil health, water quality, and climate footprints. So we have a demonstration sites representing the Northwest Illinois, Central Illinois, and the southern part of Illinois. Couple of management practices, for example, growing the soybean under the no-till system or growing the cereal rye on the major residues in the falls. Today in this talk, I will give you a brief overview about what are those matrices of sustainability, soil sustainability, and how we do measure the climate footprints or water quality and soil health, and what we could expect in the coming years from these results. Very well. So in our Illinois, we have two dominant soil types, which are alphisols and mollisols, covering almost more than 90% of the region. Our sites are located in Monmouth in the northwest part, and Urbana typical mollisols, and one in the south in the Ewing. So we have a quite nice mix of the soils, and those projects will be conducted. Give us the heads up how the results look like in one soil type compared to another. our state has a two different type of climates, and our soil, you could see on the picture on your right, Monmouth and Urbana on the one, on the represented in the blue color shade, is a typical Midwestern climate. But as we go more into the south, we have a typical different type of climate, having a more growing degree days and things like that. Yeah, Ewing is another side. Yeah, so it's a quite excited, how we are covering all the different climates and as well as the different soil types. You know better than myself that we have a dominant corn and soybean production system, and our all three locations are located in this rotation. In one of the corn bean rotation is available in all three locations. We will be testing this rotation with the both tillage system, no-till and convention till. I will be having the split of the cover crops and houses compared to the fallow plots. Just an example that corn and beans take our major of our summer growing season, and then growing on the cover crop plots are cereal rye. So it will be interesting to see how the results will be vary between the cover crop and the fallow. The one of the personally for which I am really excited about is the double crop wheat soybean rotation. So these experiments will be there for two of our locations, which is in Urbana and Ewing. Again, both this rotation will be tested under both tillage and cover crop experiments. Again, this rotation is a really intensified rotation, completed in a 2-year cycle. Summer crop corn, and then after corn harvest, winter wheat will be planted. And once winter wheat harvested in end of June or early July, then we are going to plant the fast growing soybean variety. And once soybean harvest, we are likely to put up cereal rye. So this will be a very intense crop production that we are testing in 2 locations. So it will be very interesting, how the results look like in the central Urbana or compared to the southern part of Illinois. And I am personally very excited about this intensification that how soybeans can give us that flexibility of achieving the double crop growing season. As I just mentioned, that it's a newly funded project. We established our project during this fall. Just a few things like a site preparations we conducted this fall, and also testing all kind of things. For example, for the water quality, soil sampling, baseline samplings, and we will have the gas chambers as well. We'll now talk about how the soil health metrics, and you might hear this in different presentations as well. So we measure soil health by it's a unique interaction between soil physical, biological, and a chemical environment, which leads us to the soil health analysis. We are measuring the soil biological properties through several of indicators such as organic matter, potential mineralizable carbon and nitrogen, microbial biomass, soil enzymes, soil proteins, LPA-LFAs. For the soil chemical, we know the some indicators such as what's my nitrogen content, what's my phosphorus content in my soil, epoxy, another indicator representing the active carbon cycling. Some routine when you send the report like soil pH, cation exchange capacity, and electrical conductivity are another indicators. We are also measuring the soil physical indicators such as soil texture, bulk density, and aggregate stability. So when you measure these many indicators from our field experiments, it gives us a soil health score, and it will be interesting to see how that soil health score or the things look like in one part of the state to the another, one part of a cropping system or one part of a rotation between typical corn soybean system to the other double crop soybean system. So we are quite excited to measure many of these matrices. This is one of the rare projects, I would say, in our research community where the soil health assessments are being conducted on side by side with the water quality assessment. usually, we quantitatively we do not have our numbers how those look like at the plot scale. So we are measuring the water quality through the lysimeters. These are the tiny lysimeters being prepared in the lab, installed about a 16-inch below the soil surface. They are used for estimating how my nitrogen and phosphorus leaching losses look like. It will be interesting to get the numbers, how much nutrient loss occur or how much per bushel of a soybean leads to how much nitrate loss, occurred by a per bushel of soybean production. Yeah, so it will be a quite interesting, having a side-by-side comparison between the soil health and the water quality. And this will be, I would say, one of the rare study in which we will be having such numbers. You hear too much about the climate footprint. So yes, we are also doing in addition to soil health and water quality, climate footprints measurement. We are doing this by installing the chambers at each plot and measuring the greenhouse fluxes, both carbon dioxide and nitroxide. We will calculate the carbon dioxide, calculating carbon dioxide and nitroxide. We know that nitroxide is a highly important environmental gas. This gives us a kind of a global warming potential as well from these our management practices, and then we will calculate the yield on the basis of yield. How much per bushel of soybean leads to how much carbon footprints. So again, we do not have these numbers. We talk about the carbon credits and things like that. This will be one of the unique outcomes from this project, that we will have an actual number study through scientifically in the lab. There is a two-way to gain the credit, either to build the carbon or to reduce the carbon footprint. So we know that it's difficult to achieve the carbon, difficult to maintain the carbon level, or difficult to achieve the carbon sequestration. But this GHG data, greenhouse gas emission data, will kind of provide us initial evidence, how much from certain practices we are losing the carbon or how much we are expected to gain. So there is a two-way to gain the credit, again, either to build a carbon, which is a long-term process, or either to reduce our climate footprints. This is another way of gaining the carbon credit. You might already get a sense that to gain the carbon, we need to build up the residues in the field. We need to sequester the more carbon from our atmosphere. Scientifically, we have practices such as that we are so-called regenerative practices, so-called climate smart practices. They have the same agenda, harvest as much as carbon from the atmosphere, build up into the soil. We are testing, you got kind of at the sensor, we are testing the nodal system, and cover cropping systems. Of course, the diverse rotation, how the soybeans kind of help in the continuous corn, and having the comparison with the double crop system. And they have other benefits that we don't usually, encounter, such as reducing the erosion. So that water quality data will kind of give us the rough estimates. Of course, moisture conservation is just, another aspect I will be kind of interesting into, because it will be important to see in the Ewing, especially with the double crop system, how they will look like our moisture. Do we have enough moisture left for the soybeans to use, and do we have enough moisture left for our cereal rye to take up, and then how the numbers will look like in the following corn. So it's an interesting study, I would say. Finally, I would say that it's one of the rare study being conducted in the Illinois. I would say that from which you will get a comprehensive assessment of both soil health, water quality, and climate footprints. In the future, we expect these findings coming from this project will provide you the brief overview of what you can expect in terms of a climate carbon credit from these conservation practices, and how the full season soybean versus the double crop soybean system look like, and what is in for the carbon from these two systems. Again, we as a scientist, our goal is to generate the data and help you, giving to share our perspective in a way. We want to provide you the evidence that will help you, that whether does our Illinois cropping system can potentially sequester the carbon or not. So this is a 4-year project. So we will be completely two rotation cycles. So it will give you the first how initial our that can we get a carbon credit from our system with these conservation practices. So that's all I have for this presentation, but I will be happy to take any questions or any comments or suggestions. Thank you.